Okay, so now we're moving on to pH levels, another physical indicator that scientists use to monitor and decide if the water is drinkable. Is it good enough to drink? So pH is a measure of how acidic or basic a liquid is. So if something's an acid or a base, that means it's not at a neutral level, and it's generally not a good thing to ingest, so to eat or drink anything that's too acidic or too basic. So the pH scale is a scale from 0 to 14. So you could have a pH of 0, something could have a pH of 14, and anything in between. A liquid with a pH of 7 right in the middle is considered neutral. So here you can see this picture shows you some different liquids and their pHs. So lemon juice is very acidic. Okay, you can see its pH is right around 2 to 3. Okay. Water should be right at 7. Some of these other things, like different types of soaps, are more basic. So like soft soap has a pH of 10. So generally it's not good to eat or drink anything that has too high a pH or too low a pH. You want to be around the neutral area. Okay, so using this chart, you're going to answer these two questions on your notes at the bottom of the first page. So, is coffee more acidic or basic? What about milk, and what about seawater? So, looking at coffee is right here. It says it has a pH of 5, so that's more acidic. Okay, anything from 0 to 7 is more acidic. Anything from 7 to 14 is more basic. Okay, what about milk? Milk is right in the middle, but it's a little bit closer to the acid side, right around a 6. So milk is a little more acidic. Seawater has a pH of 8, so that is a little bit more basic. So you're going to write out your answers on your notes. Hypothesize, so that means like think of or predict, why soft drinks are not so great for you based on their pH levels. So soft drinks are over here. The pH is 3. So they're probably not so good for you because they're so acidic. They are lots of acid in them. Okay, flip to the back. A water source with a pH that is too high or too low is unhealthy. The ocean has a slightly basic pH, 8 to 9, which is actually healthy for marine organisms, so for organisms that live there, but not healthy for us to drink. Water can become too acidic, so have a lower pH from acid rain. So as acid rain runs into or falls into rivers and lakes, that can make the river and lake more acidic, and that's not good for us either. Water may also become too basic, so have a high pH if many algae grow in it. So if there's so much algae, like in this pond right here, that actually makes the water have a higher pH. Alright, so here are some practice multiple choice questions. Again, you're going to answer these on your notes sheet. The first one, a company has acquired land next to a local river. 1 month after the company opened, the pH of the river dropped from 6.7 to 6.2, and the month after that, the pH was 5.9. Which effect would lowering the pH most likely have on the organisms in the river basin? So what would happen to the organisms because the pH is getting low? And it should be closer to 7. A, all the organisms would die. B, all organisms would thrive. Thrive means to do really well. C, the organisms would work together to raise the pH of the river. D, some organisms would adapt to the new pH, while others that could not would die. So pick your best answer. The next one, if a newly discovered fish species is found to live in mildly acidic water, which is the best estimate of the pH range for the water? So remember, it goes from 0 to 14, the pH scale. 7 is neutral, 0 to 7 is acidic, 7 to 14 is basic. So it says it is mildly acidic. Okay. For the first one, you should have circled D. Some organisms would adapt, while others that could not would die. For the second one, mildly acidic would match B, 5 to 6. 0 to 2 is very acidic. 7 to 8 is mildly basic. 13 to 14 is very basic. on to our last physical indicator that scientists use to decide if the water is good enough to drink. This indicator is called turbidity. So turbidity is a really fancy word, but it actually means something really simple. It's actually a measure of how clear the water is, or how many solid particles are in the water. So it's basically how cloudy the water is, or how clear it is. So a water source with high turbidity or cloudy water is unhealthy. So the more cloudy the water is, the higher their turbidity. So you can see in these glasses, here it's very clear water, so it has a low turbidity. And here it's very dirty, cloudy, you can't even see through it at all, water. This is high turbidity. Okay, which glass is more turbid? The ones on the left or the ones on the right? Okay, hopefully you picked the ones on the left. They have a turbidity of 250, while this one over here on the right has a turbidity of 10, so much lower. Okay, so draw out one of these glasses that has high turbidity in that little spot there. So I would draw out like a glass with really cloudy water that you can't see through. So soil that is entering the water in runoff can increase turbidity. Just imagine a river that has now tons of soil and fertilizer coming into it from runoff. That's just going to make the river or the lake cloudier, right? All that dirt is just going to make the lake dirtier and cloudier. So that's going to increase turbidity. After a heavy rainstorm, that can also make the water in streams more turbid. Because what's happening here is the soil is getting brought up from the bottom and into the water, so it's getting cloudier. As the soil particles settle back down to the bottom or they're carried downstream, the water will become clear again. If there's a ton of algae growing, so if you see right here all this algae growing on top of the water, that's also going to cause high turbidity because you can't see through the water when there's so much algae in it. It just makes the water very cloudy. Okay, so high turbidity is bad because it keeps plants and algae from getting enough sunlight to make food. If the water's so cloudy, like in this picture, the sun can't reach through the water to get to the plants that are growing towards the bottom of a lake or river. So those plants won't have enough sunlight for photosynthesis. So this is really important right here. A healthy water source is clear. However, if a lake becomes too acidic, like too clear, then no organisms could live in it. Because remember, they need to live in a neutral pH, so it can't be too acidic. Alright, here's another practice multiple choice question. Why is it important to monitor turbidity levels of a water system? A, frogs will destroy fish eggs in murky water. Murky is another word for cloudy. B, fish are better able to find food in cloudy water. C, water can only be used for recreation when it is clear. D, suspended particles, which means like particles just floating around, diffuse sunlight and absorb too much heat. So the answer here that makes the most sense is D. If you really think about it, the other answers just don't make any sense. D makes sense. Suspended particles diffuse. It means they push off sunlight and they also take up a lot of heat. So turbidity is also going to increase the temperature of a body of water. Okay, so now you're going to flip back to the front and you're going to fill in your chemical indicators on your notes sheet. There are two chemicals that we look at to see in a body of water to see if it's healthy to drink. The first one is the number of nitrates and phosphates in a body of water. And the second one is the salinity or the saltiness of the body of water. Okay, flip back to the back of your notes. High levels of nitrates and phosphates can be unhealthy. Remember, nitrogen and phosphorus are two types of chemicals, and they are nutrients, so it's good to have a little bit of them, but they can be unhealthy because they can lead to algal blooms. So an algal bloom is when these nutrients cause an extreme growth in algae. So look at this picture right here. It's when the algae grow way too much and cover up the whole lake or river. Algal bloom cause the water to be too cloudy. Another word for that is too turbid. And they block the light from reaching farther down in the water. So look at this picture here. Light can't get past all that algae. Okay? So nitrates and phosphates, if there's too much of them, can cause these algal blooms. These pollutants can come from a lot of different places, but mostly these pollutants, nitrogen and phosphorus, are coming from fertilizers that we use for our plants and on farms. Okay, so you're going to watch the video in the next box, so pause this video and go ahead and watch this brief video from Discovery Education about nitrogen and phosphorus. Okay, after that video, you're going to watch this video on something called eutrophication, and then answer the 3 questions about eutrophication as you watch the video on your notes sheet. Make sure you pause this video so that you can go watch that other one, then come back to this one. Okay, so a few practice multiple choice questions. The first one, you're going to answer these on your notes. How do phosphate detergents contribute to water pollution? A, by killing plant life. B, by stripping the oil from bird feathers. C, by over-fertilizing plants in the water. D, by removing carbon dioxide in the water. Okay, the next one. How might fertilizer runoff from a soybean field affect the quality of water in the farm pond? A, it increases the pH level. B, it decreases the overall water temperature. C, it promotes algae growth, which lowers the oxygen level in the pond. D, it decreases the turbidity, which lowers the amount of particles in the pond. Okay. The last one. Which is the most likely result of an increase in the level of nitrates in a body of water? A, increase in turbidity. B, increase in plant growth. C, increase in fish population. D, increase in water temperature. Okay, this first one, hopefully you picked C. Nitrates and phosphates make plants grow too much in the water, so they over-fertilize plants, mostly algae in the water. For this one, hopefully you picked C. It promotes algae growth, which lowers the oxygen level in the pond. And for the last one, hopefully you picked B. It increases plant growth. Remember, algae are a type of plant. Okay, moving on to our last chemical indicator, which is salinity. So salinity is the saltiness of the water. So scientists check to see how salty the water is, because remember, we can really only drink fresh water. We can't drink water that's too salty. So the salinity of ocean water is usually 3.5%, so there's 3.5% salt in the water. But fresh water should have a salinity of less than 0.1% salt. So they just check to make sure our fresh water has a salinity of less than 0.1%. Alright, you're going to flip back to the front one more time and write down for biological indicators, write down the word bioindicators. Then go back to the back. So bioindicators are organisms used to monitor the health of an ecosystem. So some organisms can only survive under certain conditions, usually good conditions. So scientists check to see how many organisms are living in a body of water to tell if that body of water is healthy, because organisms are only going to survive in healthy water. So for example, trout are a fish that require a lot of oxygen to survive. So if scientists find a lot of trout in a body of water, that shows that the water source is healthy and has plenty of dissolved oxygen. So they look for how much trout is in the water to see if it's healthy. Okay. Some other examples are listed here, so feel free to pause the video at this point to see this example. Okay. And then a final example is here as well.